And welcome to all you spaced out viewers. We're back with more daily space weather for you. First thing we're looking at is the SDO intensity gram here. Sunspot 2859 has remained largely stable in the past 24 hours. That's that one north of the equator. And the sunspot south of the equator, sunspot 2860, has degraded just a little bit. The likelihood of major solar events still in the forecast. So the likelihood of large flares and coronal mass ejection still there. There's actually a coronal mass ejection warning. There's one, according to the data, unfolding as we speak. There are two sort of on the way in the Earth vicinity. And I don't know what NOAA's talking about when it comes to a double strike. We'll get into it in a minute. So here's 193 angstroms. And you can see quite a few coronal holes here, a bit of a coronal hole system around the equator. You can see one in the north and one in the south, talking about these areas here. Also some transverse waves erupting right around this area. Right there. A little bit of activity popping off. Let's bring that back. Little transverse waves showing up there, like ripples on a pond. Another indication that the sun has a real surface, not an imaginary surface, not a simulated surface, but a real one. Here's 335 angstroms. Both of these spectra are ionized iron, 193 and 335. And we figured we'd bring up 335 for something different. Let's take a close-up look at the southern hemisphere. So here's a close-up of sunspot 2860. By far the most interesting solar feature in the past couple of months, really. And once again, we saw a C-class intensification while we did show prep. Shout out to the sun. Hey, the sun. If you've got comments to leave them in the comments. Tell your pals, the other stars, that they should watch our channel. So here's a sunspot 2860. This is 1700 angstroms. This is just extreme ultraviolet light. And you can see that's largely remained stable here over the past 24 hours, which is the scope of that video. The radio flux has dropped down to 89, so a little hiccup in the ramping up of the solar activity. And for you new viewers, the radio flux is a radio emission that comes out of the upper chromosphere and lower corona. So right in that small area there, radio flux is the most proportional data set to sunspot number. Here's a graph to put it in context. The black bar, the black line here is the radio flux, the red line is the sunspot number. And I just wanted to briefly look at the Space Weather Enthusiast dashboard. We do have a forecast for a brief geomagnetic storm later today, and a brief geomagnetic storm on September 1st, which is coincidentally our kickoff for a smAsh 2 MASH member. And so here's what they're talking about here. Two coronal mass ejections that NOAA thinks are Earth-directed. We don't know what they're talking about. They don't appear to be Earth-directed to us at all. And our smAsh team members were already aware of this. We put out a GIF animation last night at smashomash.com/smashTeam. So anyway, that's NOAA's forecast, and we'll show it even though we don't agree, because we've all got the ability to be wrong. So here's what the most recent data is looking like here on stereo A, which stereo A is out here at Lagrangian 0.5, which puts Earth off to stereo A's right. So Earth is off in this direction. That's the coronagraph. This is the difference imagery, which is simply coronagraph imagery subtracted from previous coronagraph imagery. And you can see there is a coronal mass ejection unfolding. Just keep in mind this data is a bit old here. It's about 6-hour-old data there. From what it looks like in the preliminary, it's all expected to miss to the south. Let's take a brief look at seismicity. And we're having a little drought here of 6.5 magnitude earthquakes here. No major quakes over the past 24, but we did see a volcanic uptick. So that's interesting. Let's scroll up the list. And just a brief look at this one here, a shallow quake at Hawaii. And yes, Kilauea is back on the list, and that is right over Kilauea. There you go. And that quake is so shallow that it occurred at 700 meters above sea level. Probably magmatic activity there in Hawaii. South Sandwich Island still seeing some quakes, including a 5.0. Mexico saw a deep 5.1, so there's a 5.1 at 122 kilometers, one of the largest quakes of the past 24. Looks like the largest was in the South Sandwich Islands region, right at the South Atlantic, South Pacific, Antarctic, and plate boundary. Here's another very shallow quake here at 1.2 kilometers above sea level. .2 magnitude quake at depth at Afghanistan. That's over 200 kilometers estimated depth. And here's a brief volcano rundown. Etna is back at it. So an eruption occurred at 1500 Zulu yesterday. Shivaluch exploding on the Kamchatka Peninsula, producing a 13,000-foot plume of ash. Explosive effusive eruption, also producing incandescence at the dome, a growing lava dome. And incandescent avalanches sliding down along the southeast slopes. Suwanosejima, strong volcanic activity there. 18,000-foot ash plume, that's an uptick at Suwanosejima. Kadavar exploding, which is located northeast of New Guinea. It's producing a 5,000-foot plume of volcanic ash. So here's Kilauea showing up in the list here. Seismic activity continues at reduced levels. Ground deformation beneath the south part of the Kilauea summit region. New magma accumulated under the caldera, and increased probability it might lead up to an eruption in the near future, so maybe some new real estate about to be created in southern Big Island, Hawaii. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Revenador exploding, 15,000-foot ash plume over Ecuador. Sabancaya exploding, 24,000-foot ash plume over Peru. And welcome to the Neo-Renaissance. Please visit our website. We've beefed it up, and there's all kinds of stuff there you may not have seen. So check it out, smAshomash.com. You can find our social media links there, as well as links to our merch store. If you click on smAsho merch, you can find this. And today's featured product is Galactic Federation Special Forces. So if you've already joined the Galactic Federation and you're unable to get results from the Space Force, would you like to free the universe? Then proclaim Universum Liberate. Universum Liberate, folks. Join the Galactic Federation Special Forces and tell your friends and foes that. Tell them Universum Liberate. Next, go into the GOES magnetometer here. We see a little disparity between the GOES 16 and the GOES 17 here around noon yesterday for the local satellite. That's local time for the satellites, folks, noon and midnight. And the Earth is in a North Pole current sheet still, as we forecasted yesterday. Keep in mind this data was 56 minutes old when we made the video. Here's the last image. And assuming nothing suddenly changes, I would say tomorrow Earth is likely to be in this red-colored South Pole current sheet. The green is the North Pole current sheet. And continuing on, here's a line of sight product. If you're wondering where the data comes from, folks, it comes from 51 ground-based magnetometers, and magnetometers out here on stereo A and out here on stereo B. Here's a line of sight coronal hole plot. It shows you the sun's B field in blue. The blue lines are the sun's B field. Red areas are South Pole-oriented coronal holes. Green areas North Pole, and you can see the ones we showed earlier in the 193 angstroms SDO video. There's a north one. There's a south one. They're not very well defined. They're not migrating trends equatorially yet, as cycle 25 takes its good old time. So here's what we're talking about. Solar flare warnings. We're more likely than not to see a large solar flare. Look at that. 65% chance of solar flares here. And yeah, so it's a beta gamma sunspot, 2860. It's got all the features required to produce massive flares. And actually, as it's approaching the limb, we're more likely to see large flares, in my opinion. We won't talk about the Earth-facing quiet effect on this video. We'll have to save that for a cosmology segment. Global geomagnetism currently pretty calm here at a level of 2. Again, we're expecting another geomagnetic storm, if NOAA is correct, from a CME, coronal mass ejection. I would tend to disagree with their forecast of geomagnetic storm coming. However, we did see some radio blackouts. So this is the C-class flare that occurred while we did show prep today, causing a bit of a radio blackout or brownout over places like the Middle East and Africa. One of the many effects of solar flares is that it attenuates the ionosphere and it causes radio signals, high-frequency radio signals, to be absorbed instead of refracted. And that's what we mean when we say radio blackout. Normally the ionosphere refracts the radio signal. I'll keep it simple by saying it refracts it. And when you see this happen, portions of the bandwidth are absorbed instead, preventing transmission. So here's the GOES X-ray flux over the past 3 days, and you can see quite a bit of activity there. It's mainly from sunspot 2860. It's a star on the star. No strikes in the proton flux. No relativistic particles have been headed our way from these recent spout of coronal mass ejections and solar flares. Let's take a look at the real-time solar wind. So there actually was a coronal mass ejection strike right here. Very weak and very diffuse. You can see a signal in the phi angle shift, as well as a tiny uptick in the density and a tiny uptick in the velocity. So that's a weak coronal mass ejection strike, and it's already gone. Perhaps that's the one that NOAA's forecasting for today. There was barely any Earth-facing components in any of the recent coronal mass ejections as far as I'm concerned. So I won't harp on it. Let's check the current density and speed. Current speed 400 kilometers per second for the solar wind. Current density 5.34 protons per cubic centimeter. And it did reach up to about 25 protons per cubic centimeter toward the tail end of that coronal mass ejection strike there. Looking pretty weak. Here's a geospace now, looking at the magnetohydrodynamic pressure around planet Earth as modeled by the Space Weather Modeling Framework. It's quite a complex data set, and you can see a little bit of variation happening here as that coronal mass ejection stream subsides. And then it should calm down in the last bit of the video here, and indeed it does. You can see fairly more consistent magnetohydrodynamic pressure there in the last hour or so. That's 4 hours of data. So here are ground magnetic perturbations, looking at Earth's B field, the magnetic field that goes through a magnet, in this case the magnet being Earth, and we're looking at changes in its field in magnetic flux density, otherwise known as nanotesla, changes in Earth's B field, geospace delta B. It's 4 hours of data. Nothing to write home about there. Here's a diagram of the solar system. If you're wondering where stuff is, there's where it is now. And there's where it'll be in 1 week. It looks like 8 days until the new moon. It's going to be a smAsh Timber 2 MASH member. Make sure you join us all day on Wednesday, as we'll be doing our kickoff celebration for smashomash.com/smash team. And thanks to all of our already joined SMASH team members, it's fully operational, folks. Fully operational for spaced out and non-spaced out viewers. So here's a star chart. We've conveniently drawn in the ecliptic. That's the moon up there in Taurus right now, right near the apex of its path across the ecliptic. The blue line is the galactic plane. It's in-the-sky.org. Today's cosmology segment is postponed. We've got way too much to do. We may make a cosmology segment later. And make sure you check our playlist. There are over 200 videos in our cosmology segments playlist. youtube.com/smashomash/playlists. We do see some minor charging hazards here for things like geostationary satellites. Nothing to write home about. Some minor surface charging hazards here over the Central Pacific. Places like Mexico about to move into the Central Pacific Ocean. Here's the 1-year chart of the electron flux, and look at the precipitous uptick. Yeah, it's been an electron storm. Our patrons would have already known. as well as our smAsh team members, as we updated about this earlier today. So here's the electron flux over the past 3 days, and this level right here, that's about 11 times warning levels. And according to the NOAA forecast, we're expecting this to return today. So communications breakdowns may occur as satellites do things to mitigate the damage or prevent the damage entirely. Here's the forecast model for relativistic electrons. And yeah, there you go. High levels. The green box is the forecast, the yellow diamond is the observation, and the forecast is for another electron storm situation today. Here's a diagram of Earth's Van Allen belts. Feel free to pause the video. If you don't understand that, distances are shown in miles there. And here's a total electron content forecast. We're seeing a little bit denser bands of electrons here. They're fairly organized, no real anomalies. Most GPS errors occur around the equator at noontime. Here's another diagram of the atmosphere to show you where the F layer is. Our next animations are of the ionosphere. Here's your ionogram in megahertz. Seeing some low frequency anomalies in the southern hemisphere. Some minor high frequency anomalies around the equator. Nothing too crazy. Here's the latest image. That's from 1615. That's from 10:30 Universal Time, rather. 10:30 Universal Time. And here's the anomaly map. This is departure in megahertz from the 30-day median. And you can see those blue areas around the equator mostly, as well as some low-frequency reddish anomalies in the southern hemisphere. There's the latest image, also from 10:30. Things looking fairly normal at the moment. Yowzers, we hope you didn't miss any of our meteorology segments, as we don't want our videos to be spaced out. We want our spaced out videos to be spaced out and our viewers to be spaced out, earthed out, and whatever kind of out you want to be. Here's a high resolution imagery, the latest intensity gram. Sunspot 2859, looking like it's about to be alpha class. I think it's already alpha class. And Sunspot 2860 still likely to produce massive flares, which is why we have a solar flare and coronal mass ejection warning still in place. Here's the latest refresh. There's the close-up magnetogram of that fairly decent-sized sunspot. And look at all this magnetic activity here at the front. It's mostly made up of South Pole umbrae at the moment, but there are plenty of large North Pole umbrae as well to interact with each other and blast a bunch of stuff out into the solar system, including photons and protons. Don't get solar flares and coronal mass ejections mixed up, folks. Solar flares are photons, coronal mass ejections are mostly protons. So we'll close things out with a couple more SDO videos here. This is 131 angstroms. Great imagery there. And some minor flares here. Don't be surprised to see a major flare. It's more likely than not, especially as it approaches the limb. Let's look at the ElTiday ground-based observatory. So here's the ElTiday observatory. This is quite current imagery. Look at these massive filaments over here, filaments down here, filaments over here, filaments all around sunspot 2860, as well as some up here. Don't be surprised to see crazy coronal mass ejections as a result of this. If you see a big flare, you might see a big CME. Here's 304 angstroms. You'll be able to see some of those filaments. And you may see some of those filaments blasting off soon. Don't be surprised. And yeah, so once again, congratulations on realizing our channel exists. Here's one more set of images. This is 304 angstroms, by the way, ionized helium. Here's one more example of SDO imagery from the closest star. Yes, El Sol. Shout out to El Sol. Thanks for all your hard work. And please continue rewarding us for hours by doing things at the same time as the channel. So anyway, thanks again for tuning in, viewers. Remember to stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. No matter how much various entities drive you to drink, please don't drink, and if you do, don't drive. Don't let them drive you to drink. Anyway, it's about time to get back to work, and may that solar wind be at your back.